Okay, so we want to talk a little bit about switching between polar and Cartesian coordinates. So the way that we're going to do this is we're going to use right triangle trigonometry. So I want you to imagine that I drop a perpendicular down here. Just as a reminder, you got theta here, you got r here. And what I'm trying to do is I'm trying to figure out the x and y coordinates. So if you project down, then the x coordinate will be that value right there. And the distance, that vertical distance, this vertical distance right here is going to be y. So what do we know? Well, we know that in general, if you have the unit circle, the y value would be sine of theta. This is not the unit circle. This is a circle of radius r, so you're going to multiply that by r. Okay. What about the x coordinate? So normally for the x coordinate would be, of the unit circle is cosine of theta. If you have a circle of radius r, that means the x coordinate is r times cosine theta, right? So if they give me r and theta, I could switch to xy pretty easily. I have the equations x is equal to r cosine theta and y is equal to r sine theta. So that's useful for going from r theta into Cartesian xy, right? What if I want to go the opposite direction? What if I want to go from xy to r theta? Well, um, this relationship is going to be a little bit different. What do I know? One thing I know is that my r is really describing circles, right? So we know that this point xy lives on a circle of radius r. So one thing I do know is I do know that x squared plus y squared is equal to r squared, right? Um, what else do I know? Well, the other thing I know is I know there's a relationship between y, x, and theta. In particular, I can use the right triangle trigonometry again. Uh, I know that if this side here is theta, this side here is y, that side here is x. Y is the opposite side, and x is the adjacent side, right? So I know that if I take tangent of theta is the opposite over the adjacent. That should be equal to y divided by x. So what I could do is I could use these two equations to help me find out what um, r and theta is. Now you might have to do a little bit of an adjustment because we know that when I take arctangent of both sides, if I wanted to use arctangent to solve for theta, arctangent has a limited domain, so you have to be a little bit careful. I guess the final comment I'll make is that polar points are not unique. So polar points are not unique. Okay. So so that's a quick description. So let me end this now, and then I'll do some examples in a second.